of AICTE ATAL-sponsored 6-day faculty development program on application of data science, enhancing teaching and research, taking place from July 28 to 2nd of August 2022. This program is thoughtfully organized by the Department of Computer Application at BCRAPC. Let us now take a moment to express our heartfelt gratitude to our eminent speaker, Dr. Subhash Karmakar, Senior Manager of Bank of India and Faculty of Staff Training Colleges, for gracing us with his presence and sharing his valuable insights. To do the honor, I would like to invite Dr. Rajiv Roy, Principal, BCRAPC, to kindly felicitate our speaker. Please, sir. Mr. Subhash Karmakar, who is working as the Senior Manager and Faculty with the premier public sector bank in India. He is associated with financing startups and new entrepreneurs for the past 20 years and developing new ideas for the success of financing startups. He has published 7 papers in ABDC, Scopus and Web of Science Index Journal. His paper on government bond has been awarded as Best Micro Research Paper by Indian Institute of Banking and Finance in 2022. And his paper has been awarded as the Best Paper in Interdisciplinary Research in Technology and Management organized by the Institute of Engineering and Management, Kolkata in the year 2021. Besides, he has also attended various conferences at Indian Institute of Foreign Trade, Kolkata, Indian Institute of Management, Bodh Gaya, IBS, Hyderabad and other reputed management institutes. Presently, he is reviewer associated with Financial Innovation, Global Knowledge Economy and other spiritual journals and has completed review of 3 papers which is under consideration of the journal. His research area includes financial markets, financing in bank with special emphasis on startups and crowdfunding. He will now discuss us about role of Jamovi Package in data analysis. Please, sir.
So, good morning to all of you. First of all, I will thank the Department of Computer Applications and BCRAPC Institute for Professional Studies for giving me the opportunity to speak before you as a guest speaker. Your topic is, I think, artificial intelligence and machine learning or only data science. Data science. Application of data science. Application of the data science. I think most of you are having some or more background, having coding or programming background. If you are not having any coding or background or this programming background, you should be with me, because persons like me do not have any programming background or coding background. And doing a research and analysis, it becomes very difficult if you do not know the programming of computer science applications. Persons are there, they know that how coding is to be done and programming is to be done. But today I am going to discuss a package which will help you to do the things without knowing any type of programming, or I can tell you that minimal programming can be done by you. Also at the same time, the package I am going to discuss with you, the base of this package, it is R. I think you all are aware with various types of packages like R, RStudio, then SPSS, then few software like Python. Okay. So this particular package or Jamovi, I think anyone have worked with Jamovi? No one has worked. I think you have worked. So actually, I have done my thesis or my PhD work with mixed R as well as Jamovi, because I didn't have any knowledge of that programming, and also time was also a constant for me. That's why I didn't want the time to write the programs in R. So I will just introduce first what is Jamovi, how we are, and Jamovi is a free software. Okay, you can use it at any time, and now cloud is also available. Jamovi cloud is also available. When I started this Jamovi, cloud was not there, only a simple package was there, and that we used to analyze the things. Right? Since the base is R, one of the important package, which is also being used in some of the foreign universities. They have replaced SPSS. Because for SPSS you have to pay some cost. No, SPSS is a very good package, but still it has some cost associated with it. But this is, since this is a free software, the first part of my session I will deliver the things which you require to install that particular package, and thereafter I will give you two examples. Even Jamovi package is such package, if you have got a data in Excel, you can just import it. Or just you can also import it from that particular file. So you do not need to worry about the data frame and all those things. Because in R there is a particular data frame. You can follow it. Okay, and in Excel you can also work. It is not necessary that you need a CSV file, because in Python or R you need a CSV file. But here you do not require a CSV. There are various types of advantage of this particular package. Now one by one. So what is that? This is an open and free statistical software that is used for data analysis and testing. Okay. Then this project, it is a community-driven platform. Jamovi is a community-driven platform for statistical analysis using various types of latest methodologies, allowing the users to develop and share the analysis. Also, you will get visuals also in the Jamovi. Visualization in the Jamovi is also important here. So we will discuss it. And Jamovi emerged from a JSP project with developers Jonathan Love, Designation and Ravi Sharigar, branching out to create a separate project which was named as Jamovi. Now, this is very user friendly, and background of this particular package is a R statistical language which it is using. And at the same time, if someone is interested to do R, the syntax will come, the code will come in Jamovi. You just put that particular code in R and you will get the results. Okay, so that is the biggest advantage. You need to worry about the codes. Okay, like in Gemini, you can do the coding of Python. If you are making some certain mistake, the AI will guide you that here there is a problem in your code. Correct it like this. So similarly here also, you will get this R code, you can just put it there and it will get the results. Okay. So current version we will deal with, that is 2.6.44. That is the current version. Desktop version as well as cloud, both the things are there. I will show you in this PPT how to download that. Before we move into the Jamovi, this is Windows installation instructions in Jamovi. Mac or home, whatever it is there, as per your own choice, you can directly choose it. I will not go into this. This is when you type in the Google Jamovi, it will come like this. Okay, and just select download. If you want to work in the cloud, you can also work. Otherwise, if you want to install it in your desktop or in the laptop or in the PC, then you can also go for download. When you go for download, this type of things will come. Two options will be there. Download directly from the browser, or if you want the Jamovi desktop, you can download it directly. So if you go for this Jamovi desktop, there are two versions available. This is the latest version, 2.6.44, and 2.6.26. It is the another version which is mostly used. I will do the work as of now with 2.6.26. So whichever version you like, you can download it directly from that particular desktop version. Now, what are the different types of pages in the Jamovi? I will show you one by one the package. No, I have not used the current version. I have only used the 2.6.26.
Maybe some current version is maybe some innovation of that particular version or changes.
Yes, maybe there, but
is it preferable that we can work?
they are recommending 2.2 to 6.26.
So that is a solid version.
Yes, solid version they are now recommending.
Okay.
Okay, that's why we have downloaded this particular version. Because when we started with Jamovi, this type of all the packages were not there. It has got a library. Jamovi has got a library. You can directly install the packages from there. Okay. And you will find there descriptives. Then you will find 5-point summary. Everything is there. The Jamovi. I will directly go into the package without wasting your time. That how you are going to do this. Today I will show you two important things. Number one, how to generate the descriptives in Jamovi, how to do a t-test, simple t-test, sometimes it may be ANOVA, then regression, and I will deal with the non-parametric data. Why non-parametric data? Because in real world, you will find this type of non-parametric. That's why a parametric and non-parametric, that is also there. So what we call actually parametric and non-parametric, that I will show you. That in case of parametric, it has got a fixed parameter. Okay. And parametric statistics and parametric test has to be carried out. What is that? For example, in data, you are taking that of only 20 students of your college, the height and weight data is there. It may be a parametric data having a normal distribution. You are getting a correlation between height and weight. But the things are not same in the real world. If I take a stock market data, or if I take such data which is running into thousands or 3,000, in that case it is not possible that data is going to a normal one. At the same time, there may be chances that autocorrelation or multicollinearity is there. So you have to check it for there also. So this particular package will also help you to find whether the data is having a normal distribution or not through various tests. At the same time, it will help you to determine whether autocorrelation or multicollinearity is there in the data. If autocorrelation, multicollinearity is there, and as well as the data is not normally distributed, you cannot go for the normal regression techniques. Thereafter, you have to apply something different. Sometimes we face the situation that we are having ordinal data. Ordinal data means, suppose you are giving certain rating to a particular soft drink, that how the soft drink is. For example, the soft drink is very good in test, or good in test, or very bad in test, or worse in test. How to measure this type of data? How to categorize this type of data? Because it becomes very difficult for ordinary this OLS to do all those things. Because the data is a categorical data. It is not a measurable data. You cannot quantify. You can quantify the height, weight, everything. But you cannot quantify that. Suppose you are quantifying that there are 30 students in your college or our college, and who is the most intelligent, weak, likewise, mediocre, something like that. So how to analyze this type of data? So then we use the non-parametric test. So our package today, it will not only help us to find out the dispersion in the data, which steps is to be taken, as well as it will help us to do some non-parametric tests very usefully. Okay, why non-parametric test? Because sometimes it happens that the data is not normal, what I told, and at the same time, there may be certain deviation in the data, which you are not able to quantify. So that's why in that case, the non-parametric regression techniques will be applicable. So those who are doing the research work, particularly in finance or something, some areas, doing some survey, in HR also do some survey, marketing do some survey. Then in certain cases we take some financial data. So it will be helpful for them to use this particular package. Though it is not a substitution of Python or not a substitution of SPS, because a lot many things are there in the SPS which is not available here. A lot many things are there in the R which is not available here. A lot many things are there in Python which is not available. But for us to have a moderate idea about the things, about your data, we can do this very easily. Okay? So without wasting much time, I should go into the details of the data. First of all, we will see the package, what are the features in this particular package. That will help you. If that file is not open, have some data on that file. So it's easier for you to identify the data. How to do an analysis with the data. Let's take some time. this particular data pertains to the COVID data during the COVID period. Okay. In this particular data, you will find in the column there are, I think you can zoom at the back end if they are able to see. That is zoom. It's visible. It's visible. Okay. Okay.
Installation of software packages
স্যার আমি রিস্টার্ট করে দেখবেন কি?
না, ঠিক আছে, দেখছি এটা চালু হয়ে গেল। ওখানে একটা পিসি নিয়ে আসতে তারপর this particular data, it contains the COVID period data regarding the different banks, their categorization, that is public sector bank or private bank or NBFC, and this you can find here, and thereafter you can find the quarter. Quarter one means from January to March, and thereafter April to June, July to September, and thereafter October to December. So these 4 quarters are there. Thereafter we are having another data here for closing prices, stock closing prices. So these, the first column you can find it here, that is the closing prices of different stock data of particular banks in that particular quarter. Quarter means we have done the average. Daily closing prices are available and we have converted into average. What is the average closing price during this particular quarter? So this is the closing prices. Then we have here, that is the change in the closing prices. That means last quarter to this quarter, what is the percentage change in the closing prices, or simply you can say that is the stock market prices of that particular bank, the changes in this particular quarter. In the next column, we are having data related to systemic risk. Now, systemic risk means the amount of capital which is required by a particular bank. The amount of the capital which is required by bank, it is arbitrary data in $1 million. The amount of capital which will be required by a bank in case of a situation where the share market value falls below 50%. So that is a risk data. Okay. And the last column you will find the changes in this particular risk. What are the changes in this risk quarterly? So we have got 4 to 5 things here. Now, name of the bank, type of the bank, and 2020 quarter wise, what is the changes in the closing prices, and what are the changes in the system risk. So risks will increase when prices will go down, and risks will decrease when prices go up. Generally, this is the pattern. Because a bank is thought to be well capitalized if it has got a very good market capital, and at the same time a lower market capital, it becomes very much risky. This is the concept. Now, through this particular, as you can see, that suppose we have to do this thing in Excel. So you can just frame the data in Excel, and each of the column, as you can find here, that you have to find here, you have to go for data, and suppose I want to change this particular column. Then how you have to change this? Just click over it. Suppose there is name of the bank I have written. Now suppose I have got to change it. So I will just put there that bank. Okay. Now here you are finding nominal, text and all those things. Nominal means some sort of categorical data which do not have any discrete value or continuous values. For example, name of the bank, it has got no quantified values. So that's why we have put it here like nominal. Then the second column, and here you can find the names also. Allahabad Bank, Andhra Bank, Canara Bank, State Bank of India, UCO Bank. Then private banks are also there. So you can find the name here, you can check it. When you move to the next column, you will find the type of bank. Type of bank, whether it is a public sector bank, or whether it is private sector bank, or whether it is NBFC. So there are 3 categories here. You have already fed it in the Excel and just put it there. Thereafter in the third column, you will find the year. So year is same for each and every bank as of now. In the fourth part, you find the quarter. That is quarter 1, quarter 2, quarter 3 and quarter 4. And in the last part, you will find closing prices. Now closing prices have got some values. Maybe some decimal values or maybe full values. Because we have done the average here. So it is not a ordinal data. Now it has got some values, so that's why we have selected here that it is continuous, not discrete also. It is a continuous data which is changing. Thereafter, we are having the percentage change in the closing prices, that is in percentage or decimal. Thereafter, we have the systemic risks, what I told you, in dollars. And again, percentage rise or fall in the systemic risks. So these are my parameters which I will define. Now, first of all, you will find here that if you want to edit something, you can go there. If you want to transfer something, you can also go there. So you can make lot of changes from here. So I have to go to the data. You are finding here variables, data, analysis, edit. Okay. So I will go for data. When you go for data, the data will directly pop up from here. Okay. And when I go for a exploration, okay, analysis. In analysis part, please see, first part is the exploration. Okay, exploration means finding the descriptives. What is the mean, what is the median, what is the mode, what is the maximum, what is the minimum, whether your data is normal, all those things will be given from here. At the same time, you can also find the relationship between the two variables from the scatter plot. I will show you. Then we have got another part, that is the t-test. This t-test actually, it is conducted when you have got a very small data, very small size data, and it has got a normal distribution. You can conduct an independent sample t-test, means single sample is there. Suppose marks of the student, class wise or something like that. You can go for an independent or independent sample t-test. Pair t-test means marks of the student and their study hours. You can find a relationship there. So you can go for a pair t-test, and sometimes a single sample is there, so you can go for a single t-test. We are not going to do it here. Thereafter, we have got ANOVA, that is analysis of the variance. Analysis of the variance, it deals with the means of two particular data. Here also, we are not going to do two particular things. We are interested here with regression. Regression, we can find the correlation matrix, we can go for ordinary least square regression or linear regression, and we can go for binomial. Binomial means, suppose I am tossing a coin. There can be two outcomes, either head or either tail. Means two outcomes are there. So either head or either tail, then we can go for this binomial if there are only two outcomes, either success or failure. Okay, again two outcomes. We can go for this binomial or two outcomes regression. Otherwise, multinomial regression, there we will use the logistic regression, that is known as log of odds. I will discuss what is odds. So logistic regression is very important because where we can use a lot many parameters. We can use a lot many your factors also while doing the analysis in case of logistic regression. So I will start with this particular part, exploration. So first part is our descriptive. So what are the things which are coming in the descriptive? Let us see. Suppose I want to find out the closing prices. Okay. And then percentage change in the closing prices. So that I am putting it in the variable. Next is split. You want to split it by type of bank, suppose. So we have got three types of bank. That is NBFC, private bank and public sector banks. As you can see, in this first part, that is the number of data which has been considered here. It is coming. It is in case of public sector bank, there are 53 data. In private sector bank, it is 65, and in case of NBFC, it is 50. There is no missing data. Now please check this particular column. চলছে ঠিক আছে ছেড়ে দাও চলছে রেখে দাও যদি দরকার পড়ে ওটা ছেড়ে ঠিক একটু স্লো ঠিক আছে ঠিক আছে ঠিক আছে So as you can see here, the data, it can give a good insight here that as you can see, since I have taken some of the good NBFCs, the mean closing prices of the NBFCs is very high as compared to public sector bank and private bank. So public sector banks, they are having a not very much high stock share market prices. So you can find from that particular data, if I calculate the mean, you will find public sector banks are having a mean closing price of 50.5, private bank 326, and NBFCs it is around 757. But in the next column I will check what are the changes in the closing prices. You see, the changes in the closing prices, it is almost same in case of NBFCs and private sector bank, except in case of public sector, there is more erosion in the change in the closing prices or stock market prices. Okay. Then I have got this median. So I think you all are aware of median. Median is the middlemost observation. So if you take into account the median in case of NBFC again, since the stock market prices are high, so thereafter the median. So accordingly, we can find here median, standard deviation, minimum and maximum. Minimum values and maximum value. Now if I go into the minimum and maximum changes in the closing prices, you see, now you can find it here that in case of this particular part, when you go for this minimum part, what is the change in the closing prices? Highest, it is highest in the, I think NBFC. Means the minimum changes in the closing prices, it is lowest in the public sector bank. Why? Still people are having some sort of confidence in the public sector banks. That's why changes are minimum. Though prices are low, but changes are minimum. So again it is going to give an important insight. But if I take another parameter, now here, I do not require that I want to take another parameter, that I want to do it quarter-wise. I want to do the quarter-wise changes in the closing prices. Okay. This will give you a better insight. You see the change. In the second quarter during COVID, that is lockdown was imposed in the month of March, what you find, the maximum change in the quarter 2. Why quarter 2? Because during April to June, it was a total lockdown phase. And during this total lockdown phase, as you can find it, in all the banks, not only in public sector banks, in public sector banks, there is change in the price of around 44%. 44% fall in the prices. Whatever the stock market prices were there has been a fall to the extent of 44% of that particular closing prices, because lockdown was all of a sudden imposed in the quarter 2. So it is giving a better insight of what the things happened, and you see how quickly you can use this particular data. Had it been R or had it been in Python, you will have to write the codes. You will have to put the data. But here, easily you can visualize the data and find out the insight that yes, during this quarter 2, we can find it, there is the maximum drop in the closing prices of stock market prices, because it was during this quarter 2, the market, it falls sharply. Thereafter, it revived during the quarter 3. And to some extent, it fell during the quarter 4. So you will find that quarter 2, it is important both in public sector as well as in case of private sector. You will find the maximum fall in the closing prices. It is around minus 61%. Now compare it. Sometimes it gives this impression that yes, there are people who are still having some confidence. That's why the fall here, it is minus 61% in case of this private bank, and in case of public sector banks, it is your 43.6%, a huge gap. It is 44% and it is 61%. Then if we compare the NBFC also, there is again a fall of 53%. So from this particular data, you are able to fetch the details that during this Q2, there was maximum fall in the stock market prices as of because of this lockdown. So this is one particular part. Thereafter, we will go to another details. What is the minimum fall in prices or maximum fall in prices? So again you can see the minimum fall in the prices in case of publics. In all the quarters, you will find the minimum fall in prices is very high. Because it was during the COVID period, the market was moving like this in a haphazard way. There was no direction. So as you can find it here, the minimum and the maximum fall in the prices are very high. And you can find it in the NBFCs, it is very high, very high. So you can consider here that NBFCs are most risky to invest during these turmoil situations. You can invest to some extent in private banks also, in public sector bank also, but NBFCs are very, considering this, NBFCs are very risky. You can also find it bank-wise. What is the status of these closing prices? If I put it like this, if I remove all those things, quarter-wise and the type of bank, if I put it bank-wise, you can get the data. It will take time, yes. Now, this is the data of the public sector banks. First, you find the data of this public sector bank. Thereafter, you will find the data of this NBFCs and all those things. You can find maximum fall. Now you find it here. The HDFC Bank, the lowest fall. If I consider the average quarterly, so HDFC Bank will be the lowest fall in that particular area. So as you know, HDFC is considered as one of the robust bank. That's why these results are also coming that it has got a lowest fall. Now in the second part I will show you that how you have to calculate the 5-point summary.
From this package, we just
Yes.
only deal with the data.
Yes, yes.
The Excel is.
You just put the data, the things will come in seconds. Actually, my laptop is not working very fast. But if your RAM is okay, then within few seconds the data will come. And it gives very valuable insight without taking into consideration any type of code.
Can you get some charts or anything?
Chart.
Pie chart or bar chart or history?
Yes. That I am going to show you. Display. Yes. Box plot is there, violin plot is there, histogram is there, everything is there. That is a good package which is being used in some of the universities. Because number one, the advantage is this free software. And number two, you can see, as I have shown you, that you can easily take into account what are the things without doing any type of coding directly. And my internet is also off. I am not turning the net. So you do not need to go for any type of expenses related to this net and all those things. So these are the advantages of this particular package. But if you want to get this R syntax, I will show you, or R code, then internet will be required. Otherwise, this code will not work. Okay, or if you want to install certain library, then you will require that. as you can see it here, that in the second part, first I have shown you these variables across column and descriptives. Then in the second part, as you can see here, there are statistics. Okay. Here, you can find out the percentiles, 25%, 50% of the median, 75% and kind. So maximum, minimum, that is maximum, minimum, then median. So you can get Q1, Q2, Q3 and Q4. Okay. So how to get this? So here you can find it out that I have given the data, and this is the maximum, minimum, and thereafter it comes quarter-wise. Thereafter it comes 25 percentile, then 50 percentile of the median, and thereafter 75 percentile. And if you want to cut it, then also you can get the same value from that particular area. Now, various important things are there in this particular part to find out the dispersion. What is the variance? Then what is the range? What is the interquartile range? I think you are aware about what is standard deviation. Standard deviations, then this range, interquartile range, everything is covered. Okay. This dispersion of the data can be found out from this particular area. Yes. As you can find it, you can find the variance. Now check the variance. The variance you will find it highest in the NBFCs. Then the variance is lowest in the public sector bank. Public sector bank, the variance is lowest means in certain type of turmoil situations, it is seen that public confidence arises in certain things. For example, public is aware of the fact that if something goes bad in the public sector bank, the government is there because the government is taking care of the shareholders. But these things are not said in the private sector bank or NBFC. That's why the results are coming like this. The variance, it is less in case of public sector banks. Otherwise, the variance is more in case of, you will find in NBFCs and private banks. Then regarding skewness and kurtosis, this is also very important. I am reducing the parameters so that you can get very good results. Okay, so what is the skewness and what is kurtosis? I think you have got the idea. What does these things do? What is skewness and kurtosis? And how we have to use it? Skewness and kurtosis, again, it is like dispersion of the data. Mostly the financial data, they have got a very fat tail. Maybe it may be your rightly or left skewed data. Maybe kurtosis, generally the data is not very, that is mean, median and mode, they are not same in most of the data. So here you will get some sort of dispersion. So how to check this further? I can check this further also with the help of this particular normality check can be done with the help of this Shapiro-Wilk test. What is Shapiro-Wilk test? It will tell you whether the data you are working, it is having a normal distribution or not. Because if it is having a normal distribution, then you have to go for certain test. If it is not having a normal distribution, then you have to go for certain test. Now here, as you can find it out, in case of Shapiro-Wilk test, you are finding in most of the cases it is non-significant. The p-value you are finding, it is less than 0.00. Most of the cases. That means our null hypothesis is rejected. Means this data is not a normal data. And why normal data is not there? Not many outliers are there. Outliers, you understand? Dispersion is more because during the COVID time, things have become aberrant. And that's why this data cannot be termed as a normal data. And the test you have also conducted, particular package, that whether the data is a normal one. Now coming to another part, that is histogram and all those things. So this part will help you. When I go to the plots, you can find histogram, then you can find box plot, you can find this bar plots, everything is there. Suppose I am going to find out histogram. Okay, so histogram will also come. Quarter wise, you will get the changes in the closing prices. Okay. Then, if I want to do a box plot, I do not want to do histogram, I want to do a box plot. Yes. Now, see very carefully. This is Q2. A box plot represent, that is, there are 5 points. One is the minimum, then thereafter it comes Q1, then median or Q2, then Q3, and finally maximum. You just look out the Q3 here, how the dispersion is taking place, and the minimum you can find it here, and what is the difference between the median and the minimum. So this box plot is an important part to study the dispersion as well as the distribution of the values. Okay, so very easily you can create a box plot out of this. Okay, very easily you can create. I think no coding and nothing else is required to prepare this type of things. Again, if you want to do a Boiling plot is also there. If you do not want to label the outlines, just remove it. If you want to label it, just put it there. Okay. Then we have got Boiling plot. I am putting there Boiling plot. Again, you can find it in the Q2. The changes in the fact, because Q2 was the most affected quarter. So that's why one plot is again same that two box plot. There are 5 points. Okay. So in this way you can interpret the data. You can go for a box plot, you can go for a histogram, you can go for a bar plot, you can go for mean, median, 5-point summary, everything you can do within your fingertips without writing any type of code, just putting the data from the Excel, just import the data. There are options, I will show you. Here are options. Special import, new, open, export, everything you can do. And results, whichever you are getting, suppose you results want to copy, just, if you want to copy all, just copy it and paste it somewhere else. If you want to copy the analysis part, just paste it and do it. If you want to export it, you can also export it. If you want to copy the images only, that also options are available in that. Okay. And in the last part, I will show you the queue of quantile plot. Okay. So these are the quantile plots of the 4 quarters. Okay. So quantile plot, what it's refer? You are finding a straight line here. This straight line, it is the theoretical quantile. Means in this way it should move. And the black line which is moving or wrapped around this line, it is related to your this changes there, that is related to that. Okay. So 2 types of quantiles. This is the actual data. This thick black line, it is the actual data, and this middle line, it is the theoretical quantile. This will also help you to find out whether the dispersion in the data. Again, here you can find in the Q2, because we are dealing with the Q2, the dispersion you can find the minimum. In rest quarters, this particular quarter, the dispersion has been the highest. So lot many things are there. Okay, that we can use it from this particular package. So what you can do it here? First of all, you can also find the mode, then you can also find percentiles, then standard deviation, variance, range, You can also find the standard deviation of means, and this is very important part. You can also find the outliers. Outliers are very important in certain cases. Okay. Yeah, these are outliers. Highest, lowest outliers. As you can see, the row number and it is getting the lowest outliers and the highest outliers. The highest figures are very low because during the COVID period, the increase in the stock prices were very low. You will find the lowest figures are very high. So these are some of the inferences which we can draw it from here. Now second, we go for regression. Okay, I think there is another part, scatter plot, that I will show you. Suppose I want to draw a scatter plot between the percentage rise or fall in S-rates and percentage change in the closing prices. Okay. Now this is the scatter plot, what you can find it. Is there any correlation between these two? Yes, yes. It is for its score, very last. Okay. Of regression. So this is the, do you find any relationship? You are not finding any relationship, okay? Because this data is not a normal data, that's why you are not finding any type of relationship here. But in the second phase, when I will go for regression, we will go for correlation matrix. This correlation matrix will help you to find out the correlation between these two. Just check it out. What is the correlation between these two? I have taken changes in rise and fall and here. What you find? Is there any correlation there? There is no correlation in the Pearson correlation matrix. Actually, Pearson matrix, it is used for normal data. And this data, since it is not normal, I will not go for Pearson, I will go for Spearman. What you find? Get the results. It is significant. Means a correlation exists between the fall in the closing prices and the changes in the risks. And you can get the p-value just increasing the font size. There. What is that? That is a negative correlation, a very strong negative correlation during the COVID between changes in the closing prices and changes in the risks. Means when prices will increase, risks will decrease, and when the prices will be decrease, the risk will increase. And there is very strong negative correlation. That's why I told you, first of all, check whether the data is normal or not. There are lot many things to check whether the data is normal or not. You can also find it from the theoretical quantiles, or you can also check it from the normal test. There are lot many tests to find out whether this is Sapira milk is one test. You can use a lot many tests like Jarkavera test is there, and all other tests are there which can be used to find out whether the data. But here, at a simple glance, you can get whether the things are okay or not. And when I use the Pearson, because this is not a normal data, that's why results are not good. But when you went for Spearman, Spearman is used for data which is not a normal one. So there you can get the result. So let me first complete it. So now, as of you are sure that it is not a normal data. If it is a normal data, you can go here for regression, linear regression. Now suppose the dependent variable, it is percentage rise or fall in stakes, and and covariate, it is percentage for closing prices. Factors, suppose it is type of bank and quarter. Okay. Now I have given something here so that you are getting the codes also. Please look it carefully. There is a syntax mode here available. On the right hand side, you can find it, the syntax mode. If you click on that particular syntax mode, the output will be automatically generated. So you need not write that particular output. As you can see, this is the link which is there, and this is the R code which has been generated. So you can do a lot many things. Then we have got a thing here which is known as module. So module containing Jamovi library. So since net is not there, so it will not come. But you will get a lot many packages. Next chapter let us slow हो you will get a lot many packages. The packages you want to install, you can directly install from the Jamovi library. This is another feature. Then you can also go for here, that is, suppose I want to save this particular data somewhere else, so that I need not write to do all the things again. So you can directly go for save as. Suppose I write save as, and thereafter you just browse the file where you want to, folder where you want to save it, and thereafter just save it.
The extension of that file?
OMB. It is OMB.OMB, and it will be there. If you require the file at a later date, just click on that file. It will come. The whole thing will come. So you do not need to write all those things again. Okay. Then we can go for new. When you go for new, a new page will open. A new page will open. Then when you go for special import, you can import something. And there are things which are available also here, which you can use. So this is all about this particular package. And then I will go for this regression part. Now, this I am doing the normal linear regression. What I am finding, as you can find it here, there is a model builder. Model builder means what are the predictors. For example, I have taken here that changes in the systemic risks, and how these changes in the systemic risks is being predicted through various types of variables. Means this is independent variable, and these are the columns for independently of this independent variables. Means my dependent variable, it is percentage fall in or this S-RIX, and my dependent variable, it is covariate independent variable, it is changes in the closing prices. Okay. So as many as choice you can go for it, as well as you can go for certain factors which are also influencing this particular changes in the systemic risks. For example, I have taken here type of bank. It may be the public sector bank, it may be NBFCs, and also the quarter. So let us see what are the results it is coming. But before we go to the results, these are the predictors. What are the predictors? Means what are the things which are going to predict the changes in the systemic risks? Number one, that is changes in the closing prices. Number two, type of the bank. And number three predictor, it is the quarter, whether it is Q1, Q2, Q3 and Q4. So this I have put in certain block. If you want to remove it, you can also remove it from here. Just put it here. The things will change. Okay. If you want to add it, just add it. The things will change. Okay. Now, this is the reference level, because what is the minimum reference level? So public sector bank has been considered. So results will be created based upon considering this public sector bank as a reference and Q1 as a reference. That is Q1 as a reference. Okay. Thereafter, we have got another thing, that is assumption check. This part is very important. What are the assumptions in this data? Whenever we are going to do OLS or linear regression, what will happen? There should not be any auto-correlation. There should not be any co-linearity. Now, what is auto-correlation? Suppose I have taken the data of State Bank of India in Q1, State Bank of India in Q2, State Bank of India in Q3 and Q4. Because I have taken the same data at different period of time. That means we are forming a time series. We are taking the same data at different point of time. It may be there, this data, they are having some sort of correlation between them. Maybe, it may be. Then we have got this your collinearity. So one is autocorrelation and next one is the collinearity. Collinearity means the data may be collinear to each other, or there's maybe that some sort of collinearity exists, and for that person we will check out two important things are there to check it out. One is Darwin-Watson statistics and second one is your this VI. These things are very important when you check the data. In the first part, you have taken care of the fact that this data is not a normal data. In the second part, you have to check whether any autocorrelation exists or whether any collinearity between this data which we have taken exists. As you can find it, the Darwin-Watson statistics is telling that there is no such autocorrelation, because as you can find, the p-value, it is more than 0.001. So that is significant. So we cannot tell that this data is autocorrelated, it is fine. Then we are having variation inflation factor or the VI. The VI, what it suggests? It suggests whether any collinearity exists between the data or not. Okay. If it is close to this VI, can be 1 to 4 or it can be, when it ranges, again this Darwin-Watson statistics, it should be close to 2. When it is close to 2, that means there is no autocorrelation. If it is less than 2 or it is more than 2, correlation exists, autocorrelation exists. Similarly, this VI value should be around 0 to 4, there is a range. Darwin and Watson, it is also 0 to 4 and here also. If this collinearity exists, then it may be there that it should be more than 1 or it may be close to 2, 3. So this type of things here, it is not there. If it is there, then again we have to go for time series analysis. If autocorrelation exists in the data, then you have to go for time series analysis. There are lot many things which you can do for time series analysis. The models are totally different. At the same time, when you are finding that there is no autocorrelation as well as no collinearity in the data, then we can go for the next part, that is normality test. Again, this data is not normal, so here you can check. Then you can find for the model fit, means which model will be important. As you know, greater this R square value, the greater is your model fit, means better model is there. Okay, so we will find out adjusted R square also. And this AIC and BIC, it should be as low as possible. Okay, so let us check it, what results we are getting. As you can see here, the R square value is not very high. That means this model is not a very good model. And at the same time, you can find this AIC and BIC value are also very high. This should be as low as possible. AIC and BIC, they are being used to find out the best model. So that should be low. So that means in this particular parameter, we cannot use this linear regression. Okay, because the results are not supporting. R square value, it is also low. And then we can go for overall model test. What do I find here? Let us go for overall model test. So when you go for overall model test, what we find here, that is we should go for this R value, this P value. We should check whether the P value it is lower than 0.001 or not. Then only it will be your model will be validated. As you can find it, the P value is not less than 0.001. That means we cannot use here this linear regression to get a better fit or get a better model. Then we have to go for something else. Then we can go for multinomial, because we cannot use here binomial. For binomial, we require only two outcomes should be there. So for multinomial, we can consider that type of band. Suppose I am considering the type of band is the dependent variable and percentage changing for closing price and falling asterisk. And again, we are checking that suppose these factors it is quantifies. Okay. Now again the same thing will come. Now again model builder, the same thing, reference level you have to take care of. Then in case of model fit, we go for overall and these two pseudo R square. Pseudo R square, this is particularly important in case of logistic regression. So again, R square value has to be checked. As you can find it here, I think it is the latter part, yes. You can find it again, the R square value, they are very low. Okay. Now, how to increase this R square value? You can go for this. Suppose I am taking here what? Now let us check R square value and this I take type of band. Yes. As you can see, the R square value now it has improved from further. So just changing the parameters, you can check it out, which is the best model, and at the same time, you can find the P value. The P value, it is significant, means it is validating your model that it is a good model. We can add also a lot many parameters. Suppose we are adding here the closing prices and this one. Certain improvement is there in the R square value. So again, if lot many parameters are there, that I will show you in the next example. We improve the parameters one by one and check it by excluding and including that what is the maximum R square value you are getting. Because when maximum R square value, it is something around 0.7 or more than 0.5, 0.6, and at the same time, the P value, it is less than 0.001, then in that case, your model is validated. But before that, you have to check it whether any autocorrelation exists in your model, or any collinearity exists in your model, or the data is a normal one or not. All the things can be checked here. Okay, now, any questions up to this? I will come up with the next example with ordinal data, because there the data we cannot find any ordinal data. But now I will do something with ordinal data. Okay. So another sheet is there. Just close it. Now this is a data where we have taken the crowdfunding campaigns which have been run in India during the past 14-15 years. Because crowdfunding means collection of money from different people depending upon their activities. These are not donation based. These are innovative crowdfunding data. Innovative means, suppose I am preparing a particular product, a good product, I am going to launch it, but I do not have any capital or money. So this type of products are there. Sometimes it may be for charity causes are also there. So this particular data, it has been taken from Kickstarter. Kickstarter is a very renowned platform which is run in US, and we are having campaigns from all the countries. Okay. In this particular data, we have got certain variables. Like this, first one is, this is the name of the campaign. Okay. Then this is the number of funders. Number of backers or funders means persons who have funded this particular project. That is number of backers. Then this is a categorical variable where we have taken different categories. That is more than 500 backers, less than 200 backers, more than 200 backers. Now, what I am going to analyze that how these situations are going to affect the funding pattern. Because in this case, we are taking the variables which cannot be quantified. If it is more than 500, whether it is effective, or more than 200, whether it is effective, or less than 200 funders, whether it is effective, in this way. Then in another part, I have taken, that is, what are the type of campaign? There are different types of campaign. Video games, food or restaurants, then your playing cards, documentary. So lot many things are there. So type of campaign, again, there is one categorical variable. Then updates. Update means, suppose a campaign is being run and the creator of the campaign means those persons who have launched that particular campaign, they are giving some update on the platform. That yes, this particular campaign is launched. Yes, these things we are providing through this campaign. So certain updates they are giving. So that is number of updates. Again, another categorical variable, that is update category. More than 50 updates in a campaign, less than 20 updates in a campaign, more than 40 updates in a campaign, and there are lot many categories. You can find it. More than 20, more than 30. So these are different variables in the update category. Then this is very important. That is my result. What is the funding percentage? Suppose I want 100 rupees for my campaign, but I have got 400 rupees collected. That means my funding percentage is more than 100. It is something around 400. Okay, so this gives the funded percentage of the different campaigns. Okay, and finally, this gives more than 1,000, more than 100,000% funding, more than 100% funding. Okay, and these are three categories. Then comments. Comments are given by those persons who are funding that particular project. They provide comments. Yes, this project is a good one, or this project is a bad one. So these are different types of comments which are being given by different types of persons. So again, we can find out a categorical variable depending upon the comments. For example, less than 40 comments, more than 60 comments, or more than 40 comments. So these are different types of categorical variable, and these are different types of this continuous variables. All those things are there. Now, simply I will go for this regression part. Multiple. Here, what is our dependent variable? Our dependent variable should be funded percentage, because we are concerned with more funding. Because anyone will be concerned with, if I want 100 rupees, if I get 1,000 rupees, that will be beneficial for me. And if this is increasing, what are the factors that are affecting this? We will check whether updates are affecting this. We will check whether funders, number of funders are affecting this. Or we will check whether the comments are affecting this. though there are lot many factors, we will check these factors one by one. Suppose we are having number of packets, updates, and comments, and in this part we are having update category, comments category, and backer category. Backer category I have not used backer category. Okay. So this is your result, 0.55. Now I will go for this regression analysis again. Means what I am getting 0.598. Okay. Now I will go for another test here, that is known as likelihood test. Why likelihood test? Likelihood test is the post hoc test or to check the robustness of the result. I am getting not many factors, but this omnibus likelihood test, it will point out which factor is important and which is not important. Though my model is showing that it is significant, it is having a p-value of less than 0.001, but I have got lot many factors like number of backers, updates, comments, update category, comments category and backer category. But out of this, when I go for this omnibus robustness check, what I find, only comments is significant. The other categories are not significant. Then how to improve my model? So in this case, as you can find, the highest number of p-value, it is in update, okay, as well as in the backer category. So let us delete it. Now again check the results.
Sir?
Yes.
How we are choosing the co-variables and factors?
Yes. This is the dependent variable. Means I have to check which are the factors which are affecting this. Okay. Now I have got lot many factors here. Suppose update I am putting here. Then I am not putting. I have already put here two factors. That is backer category. Okay. Now when I put this, your results are significant. There is no problem. R square value is also close to 0.6. Everything is okay. But out of this, all these factors, what we are finding, that only comments are important. Comments are important. Means, if the backers or the funders are commenting more, then funded percentage will increase. This is the simple thing which we can find out. Now, this lower portion, which is the omnibus likelihood test, it is the robustness check. Whenever you do a regression model, you should check the robustness of the model also. Why? This robustness check will help you that which are the factors which are influencing this. Otherwise, from the model fit measure, it is not possible for you to find out which are those factors which are mostly affecting that. Okay. Now, in this case, you find higher p values with updates and backer categories. Okay. Updates and the backer category, they are having higher p values. If I have to increase the R square value or increase the effectiveness of the model, then I have to discard this because this is having higher p values. Lower p values should be there, but higher p values have to be discarded. So that's why for choosing this, we discard these two things. Number one, update, which is having a higher p value of 0.518. We require a p value close to 0.001, but these are very high. So that's why I remove it. Again, from this particular portion, now you can see number of backers. If I remove this, what happens? Then backer category is also there, or comments category. So comments are having, again, so from this particular model, we can find out that yes, comments are having some significance or comments are having some importance. But at the same time, if I take into account that not funded category, now I am going to take backer category. Means how many backers have backed that particular project and how it is being influenced by comments, updates, or funded percentage and category. So here we can check it here. There are lot many factors which are important to the number of the funders. That means more number of funders. If there are more numbers of funders, more funders are going to be attracted in this particular project. Then it has got some relationship with the updates. Means if a creator gives more and more updates, then more number of funders will be attracted to the project. It will be also having some funded percentage is also having some influence. And lastly, the comments are also having some influence. So here we get three factors. But in case of funded percentage, we get only one factor, that is the comments. So it is not like that. Funded percentage will depend upon the number of the backers always. So funded percentage increase will also depend upon the number of the comments which has been given by the backers. It may be the situation that some of the backers are giving more comments and people are more attracted towards funding. It may be. We do not know the relationship. Now there is another part here that I will discuss. Odds ratio. You get an odd ratio here in this part. Okay. So what is the odd ratio which we use in case of logistic regression or non-parallel? Odds ratio means the number of the odds. For example, if you are tossing a coin, the probability of getting a head as well as getting a tail, it is 0.5. Okay. Now what is the odd ratio? That is 0.5 divided by 1 minus 0.5. That is the formula. 0.5 and getting a not head, that is also 0.5, 1 minus 0.5. So 0.5 by 0.5, that becomes 1. That becomes 1. So it is like this, P by 1 by P. So probability of getting a head, that is 0.5, and probability of not getting a head, that is 1 minus 0.5. That means 0.5 by 0.5. That means 1. Means there are no odds. There are equal chances of getting a head or tail. But if it is 1.8 or if it is 2, means the chances of the odd is twice, or chances of the odd is more than 1.8 times. That means chances of getting a head is twice that of getting a tail if it is 2. And similarly, we will get it here that we are getting the, and if it is less than 1, suppose it is 0.8 or suppose it is 0.7, then chances of getting a head is less than 1, means chances of getting a tail is more as compared to it. That means odds. What are the chances of getting a odds in an outcome of any particular event? That is the odds ratio. As you can find it here in the upper portion, funded percentage, it is mostly close. It is same in case of, now I am comparing the backer category. There are two backers, one is less than 200 and one is more than 500. Now what is the difference between these two? Why are the differences are there? Suppose in case of comments, it is significant in both the areas, but here you do not find any significance. So in case of comments only, you are finding a significance between the two categories, one category with backer of more than 500 and another category of backer of more than 200. Okay. Similarly, we will go for another categories like more than 200, more than 400 and more than 500, again, you are going to get no significance here except in the funded percentage. So every p-value and what are the distinct differences between each and every category that is shown in the table, and the odds are also shown in the next part. So that is the important part which you can derive in a logistic regression using a lot many parameters. You can also add parameters here also. Suppose I have taken only 2 to 3 parameters. You can use update category, type of campaign. Now let us see what happens if I use those all. And what are the things which are coming? It will show you. Is there any change? So you can take as much as parameter, multiple parameters here, and find out the best model which fits with a greater R square as well as a lower p. Why this type of result is coming now? 1, 1, 1, 1. This type of result it is coming because I have taken funded percentage here also and funded category. So there is some sort of auto correlation which is there. That's why this is coming like this. If I remove this, I have taken funded percentage and I have also taken as a factor funded percentage category. Both are same, coming from the same data. Means auto correlation now exists between the data. And what is happening, you can find it in the result. A result which is coming with 1, so none of use. So I have to remove it. Either I have to remove any one of it, I remove it. Now check the result. So this auto correlation now exists because this funded percentage, again it is coming like that. Means some sort of auto correlation is there in this particular data. Then I will remove this. So this type of removing of the variables and addition of the variables according to your need, it will help you to create the perfect model for it. Now again it is coming 1, then there is certain problem in the model. So this type of result, suppose it is coming as 1, 1, 1, then non-significant. There is no significance in this particular result. So means what is happening, our factor is there, comments, and we are taking also the figure which is being derived from that particular comments, because I have taken comments and type of campaign. So both the things they are correlating with each other. That's why the result is coming like this all of a sudden. Okay. So we were concerned with this particular category, funded category, or this much, and thereafter we were there type of campaigns, removing that, comments category and backer category. Okay. And we can get this funded percentage also, type of campaign, name of campaign. Okay. Now in the last part we have got estimated marginal means. Estimated marginal means will give the probability. For example, I want to know the probability that this much funded percentage, what is the probability of getting with that much update. Suppose I want to find out that if it is more than 100%, then what should be the update and what should be the probability of the update. That can be also calculated. And we will also find out a marginal table. Yes. This is the mean update. This is the mean, then this is the mu mean, means means minus standard deviation and last one. If it is more than 1000%, 100%, then update should be close to the mean. So if you want more than 1000%, then 100 should be close to the mean. That probability is 0.515. Now, if I take another category, I take comments category, then results will be much better. Now you see, if it is more than 1000 comments and funded category is more than 1000, what is the probability? 0.0. If it is more than 1000 comments and more than 100%, then probability is 0.95. Means 95% chances are there when your comments are more than 1000 and your funding percentage will be more than 100%. Similarly, if I take less than 40 comments, see here, if it is more than 40 comments, then what is there? 59% or 60% chances are there that your funding will be more than 1000%. So that is the astonishing results which is coming up from this. That if you are posting more than 40 comments, then 95% chances will be there that it will be more than 1000% funding. So in this way, not only you can find out the probability, you can also find out the probability chart also, depending upon the table. You can also get the probability chart. So that's why these particular things, they are very important, and once you validate your model, this is your model, it is significant, and to find out the factors which are important, you have to go for this particular omnibus likelihood test. That is very important for us. So a lot many things can be inferred out of this. Now anything, I think it is becoming tough for you. I am seeing the faces. Something is becoming very tough to carry forward or catch. If anything is there, you can tell me. Nothing is there that if some portions you are not able to understand, you can tell me. Practice it, yes. Because for any package, you require a thorough practice. That is very necessary. Now some basic things I will show you how to input that particular package. Now I will open a new page. This is the new page. When you start with, you just open a new page. Okay. Now suppose I am having a data here, data set. Sample scientist. Okay, I am taking this data set. I do not know what data is there. I will just input the data in that particular Jamovi package. This is in Excel. You can format data in Excel. Okay. Now this is the data sheet of your systemic needs. So just what you do. Okay. So you just copy it. Suppose see. This is your sheet.
So is there an option to import?
Yes, you can also import it. You can also input it. Now you change. First of all, this color. You want to change the name? Just change it. That. Okay. Then another color. Type of. Accordingly, you can change it. At the same time, if you want to edit something, suppose you want to edit something, you want to delete this, okay? So you can also edit, if you want to edit the name, here also you can edit the name directly from here. Now suppose you want to delete any row or column, suppose you do not want this lava brand, just what you do, you just delete it. Delete row.
All the errors were deleted or particular row?
That particular row is deleted. If you want to delete, that particular row will be deleted. So again, you just find the data whether it is okay or not. Now, whenever you are checking the data, suppose this is already it has taken that it is a continuous, and these are not continuous. These are ordinary variables, ordinal variables. So it will fetch directly. that what is the ordinal data and what is the continuous data. If there are certain things, because system cannot interpret that suppose this is a continuous but system is showing that it is ordinal, you have to change it. Suppose you want to change it. Suppose this one, you want to change it to ordinal. You can change it to nominal, no problem. Data type already changed to text. Already changed to text. But when you go for this continuous, already changed to decimal. So in this way, you can also edit and change the data.
Can you find any null values there or not?
Yes, null value can be also find.
How we can find that?
You see, if there is some certain missing value or certain values which are there, you can find it directly. Suppose I am missing it. I am putting in delete. Okay, then I am also putting in delete. Then I am also putting in delete. Then just go for this part. Test it. Okay. Then suppose I have taken this. You see, missing values are being shown. One value is missing. So there is not full values there. So that is shown. That what are the values which are missing. Then you can find it here from here, whatever you want to find. Now suppose you want to descriptive, you want to go to the data. Okay, from here you can go to the data directly. You want to go to the results, then again the page will come. Just click it here, on the descriptive part. The results will come. If you want to go to the data, directly go there. Now if you want to edit something or transfer something, okay. Suppose you want to transfer this one, using transfer, create a new transformation. Okay, you can add a certain code here also, or you can add a certain value to transfer. Sometimes we require to transfer into logarithmic because it is not a normal data, you have to go to transfer into logarithmic data. Then you can also do it from directly from here. So there are formulas also, compute. Formulas are also there. Okay, that you can use it. See here, log. You want to convert particular column into log. Log of base 10, you can also convert it from here. Okay, so these are the things which are available. You can use the formula also. Sometimes you want to convert to exponent. So these are formulas which are available here. Not many formulas. Mean, rad, silly, standard deviation. Okay. Okay. Split text, date value, age lookup, everything is there.
Transform for a particular
Color. Or a particular, you want to data, you want to transform into log of base 10. So that it becomes a normal data. You can change it. What we have done in logistic regression, we have just converted your data into log. Why? Because the data was not a normal data. That's why we went for logarithmic conversion. Thereafter, we have done the regression. That is very important part of this. Apart from this particular area, if you want to do principal component analysis, in the analysis part you will find it. Binomial, goodness, paired sample, log linear regression, these are also there. And factor analysis is also there. If you want to go for principal component analysis, that can be also done. I am not aware of this particular package. But if you want to go for this, you can also go for it. Okay, that can be also done. Yeah, principal component, because I am not working that area. So principal component analysis will also do. That you can also do, find out the eigenvalues and all those things. Okay. So I think more and more practice, you can become more and more comfortable, and accordingly your need, become tailored the particular package. Okay. And whenever you require the syntax, you can directly download it from here. I think it is a good package, at least, so that you can work it. Okay. Yes. I have finished it. Now there are questions. If any questions are there, you can ask. Because see, I am not a person from neither statistics and nor this programming language. So for me, it was very difficult to do these things. That's why I have learned this particular language. It was very helpful because you can introduce a lot many factors at a single time and getting the result of that. Even you can do graphs and all those things, scatter plot, graphs and everything. And the basic checking you can do. Always you should do 2 to 3 things when you get the data. First of all, arrange the data. You can arrange it in a panel data regression type also. What to do? Check the data whether it is a normal distribution, check whether auto correlation exists or not, and check whether collinearity is there in the data. In most of the financial data, we go for co-integration method or time series analysis. Time series analysis, we there go for this auto regression models and all those things.
Maybe is also possible here.
No, here is not. Okay. Suppose you are going to do some time series analysis. There you have got another package. If the internet supports me here, I can provide you that. I will provide you certain things which may be important for you for this. Granger positive models is a one here. Granger positive model or time series analysis. I will give you another thing that will help you directly calculate it from the site. Yes.
Is there any tutorial
Regarding this.
for beginners?
You go to the package itself, every tutorial is there. From the Google itself, you will get. There is no specific tutorial for that particular part. Suppose you want to go for certain time series analysis. It will take time. Internet doesn't transfer. And whenever you go for, I think you all know, whenever you go for validation of the model, the R square value you should check it, and the B value. These are the 2 things which are very important. And you should also go for a robustness check of this particular model. Because whenever you are going to publish a paper, simple linear regression or your simple all those things will not work. You have to go for a robustness check. You have to use 2 to 3 methods to validate your result. That is it is okay. Okay, my net is getting some slow. We have a site which is known as WESSA. You can just type it. The calculator calculate time series analysis. It will come like this. You can put the data and the results will be there. Even the code will be also there in that case also. Okay. If you go first, I will show you. It takes time in this particular reason to run the internet. Yes, you can go it. Just setting it up. That is more faster. WESSA. Just write in your Google. Just write in the Google time series analysis calculator. Analysis calculator. I think you have got it. Time series analysis calculator. this one you can find it. Okay. If I this is the home page. Okay. This is the home page where you can use a lot many things are there which you can analyze directly from here. Then is pre-statistics again, interquartile range, the histogram, partial correlation. Then regression software you can get it multiple regression equation. Then you can also generate various types of plots. And the last part, the important part here, that is time series analysis that you can go for it. Okay, univariate and multivariate time series analysis. Just put the data. ARIMA you can also do. Okay, and you will get the R code also from this particular site. Again, just refer in your calculation. You get the R code also. It is also very helpful site which you can use without directly coding the things. Okay. A lot many things are there. ARIMA forecasting, including ARIMA forecasting. Just remember the site, to go there in the home page and directly calculate it, put the data and directly calculate it. That can be also done. So it is www.vesa.net. WSS. But better to use the packages rather than using this. Okay. Because whenever you are using the packages, you have to refer that we have used that particular package. So you can use that particular package here. And better to use that particular packages, either SPSS or R or Jamovi. Any more questions?
ডেটাটা নরমাল না নরমাল না ওটার ক্রাইটেরিয়াটা কি বললেন?
ডেটা নরমাল প্রথম হচ্ছে একটা টেস্ট করতে হবে। ওখানে সাপিরোভিক টেস্ট আছে। সাপিরোভিক টেস্ট যখনই করবেন, যদি নন সিগনিফিক্যান্ট থাকে, মানে লেস দ্যান 0.001, তার মানে কি হচ্ছে ডেটাটা কিন্তু নরমাল নয়। যদি 0.001 এর বেশি থাকে বা 0.05 এর বেশি থাকে, তখন কিন্তু ডেটাটা নরমাল ডিস্ট্রিবিউশন। নরমাল মানে কি? নরমাল মানে অনেকটা এরকম দেখতে হবে। ডিস্ট্রিবিউশন কেউ আমাকে জিজ্ঞেস করছিলেন না, স্কিউনেস প্যাটার্ন। নরমাল হলো অনেকটা এরকম। এখানে মিন আর মিডিয়ান আরেকটা হচ্ছে মোড, এটা মাঝখানে। এবারে যেটা স্কিউনেসটা হয়, একটা লেফট স্কিউ থাকে এরকম, লেফট সাইডে থাকে, আরেকটা থাকে এরকম রাইট সাইডে। রাইট সাইডে। আর ওটা হচ্ছে আপনার কার্টোসিসটা তিন রকম থাকে। একটা ফ্ল্যাট কার্ভ থাকবে এরকম, একটা এরকম পিক হয়ে যাবে, আর একটা মেসোকার্টিক থাকবে, মাঝামাঝি থাকবে। ঠিক আঁকা বড় না, ঠিক আছে? তো একটা মেসোকার্টিক থাকবে, একটা প্ল্যাটিকার্টিক থাকবে, ঠিক আছে? পিক থাকবে, লেফটোকার্টিক থাকবে। আর স্কিউনেসের ক্ষেত্রে একটা রাইট স্কিউনেস থাকবে। এবারে স্কিউনেসের যেটা হচ্ছে রাইটে যখন চলে গেল, তার মানে মিন যেটা মিডিয়ানের থেকে বড়। হ্যাঁ, সেটা কি হবে? সেটা হলে কি হবে যে ফাইন্যান্সিয়াল মার্কেটে আমার যেগুলো কাজে লাগে, যদি ইনভেস্ট করতে চায়, সেটা যদি রাইট সাইডেড হয়ে যায়, তখন তার প্রফিট হবে। রাইট মোস্ট হবে, সেখানে সুবিধা। এটা হচ্ছে বাকি বেশি কিছু জানার থাকলে স্যার আসছে, এগুলো স্যার ভালো এক্সপ্লেন করতে পারবে। স্যার স্ট্যাটিস্টিক্স নিয়ে করেছে, আপনার স্ট্যাটিস্টিক্স স্যার ভালো বলতে পারবে। জিনিস স্যারকে জিজ্ঞেস করবো, আরো ভালো করে বুঝে দুটো তিনটে জিনিস জিজ্ঞেস করবো, আমি বলে দিচ্ছি, যেগুলো আপনারা একদম বুঝতে পারেন। প্রথম হচ্ছে অটো কোরিলেশন, এগুলো জানতেই হবে। অটো কোরিলেশন, আরেকটা হচ্ছে অটো কোরিলেশনের ডাব্লিউ যেটা দেখা, ডাব্লিউ ওয়াটসন স্ট্যাটিস্টিক্স আর রিয়ালিটি, এই দুটো জিনিস কিন্তু জিজ্ঞেস করেন। এই দুটো না কনসেপ্টটা বুঝলে এগুলো পুরো অ্যানালাইসিস করা বেকার হয়ে যাবে। ঠিক আছে? একটা মাল্টি কোঅর্ডিনেটিং, একটা অটো কোরিলেশন, দুটো জিনিস জিজ্ঞেস করেন।
With this, we have come to the conclusion of this session. The data abstract of this session is in an age of data science and AI-driven decision-making, accessible and reversed statistical packages are essential for researchers, students, and professionals. This session introduces Jamovi, a free and open source statistical software designed to make the data analysis. Built on the R statistical language, Jamovi offers the seamless point and click interface, making it ideal for users who have less or little programming knowledge. Participants had learned how to import data, conduct descriptive and inferential statistical analysis, generate visualization, and interpret results. The session covered common statistical techniques such as t-test, ANOVA, correlation, regression, and non-parametric test, with practical demonstrations using research and industry dataset. By the end of the session, participant has been occupied with the skills to confidential conduct statistical analysis using Jamovi and apply the result to their research and professional projects. Thank you, sir, for the session. Now I request our co-coordinator, Professor Pradipto Roy. Sir, please.
Before that, please call everyone.
Okay, the first one is now the photo session time. So please come forward to the